Good morning. Today we deal with the type number of a control system. We've already seen few other characteristics of control system, which includes the characteristic equation, order of a system, and then poles and zeros of transfer function. This is the next concept, which can be found out using a transfer function. So suppose your transfer function is in the pole zero format, where g of s is equal to k dash s plus z1 s plus z2 divided by s raised to n, denominator s plus p1 s plus p2. As you already know, the z1 z2 z3 etc. represents your zeros of the system, which are the roots of your numerator. p1 p2 p3 etc. represents the poles of the transfer function or the poles of the system, and it is the roots of the denominator, and the denominator equation is what you call as the characteristic equation. We have also learned another concept, which is the order of the system, and order of the system is given by the highest power of s in the denominator. Okay, so this type number of a system is again found out from the denominator expression, and as you can see, a term s raised to n. This is going to denote the number of poles at the origin. So if your expression is having no poles at the origin, you are not going to have a term there. So system which has n poles is going to be known as a type n system. So if your S is having a 0, if you don't have any poles in the origin, you call it as a type 0 system. If you have a denominator, you have a S term, or you can say this is the number of integrations in the system. N is also going to indicate the number of integrations in the system. Okay, so if your N is 1, then your system is a type 1 system. If your N is having a value of 2, that is in the denominator you have the expression S square, then it is a type 2 system because there are 2 poles at the origin. So whatever is the value of your N, your type number is going to be the same. So I repeat it again, type number is denoted by the number of poles at the origin. So let's see a few examples. The first expression is k by s into s plus 1 into s square plus 6s plus 8. As you can see, the highest power of s is going to be 4. So the order of the system is going to be 4. And the characteristic equation is going to be s into s plus 1 into s square plus 6s plus 8 is equal to 0. You don't have any zeros in this for this system. And the poles are going to be, you have a pole at s is equal to 0. You have a pole at s is equal to minus 1. And once you solve this quadratic equation, you know that you have 2 poles, one at minus 4 and other at minus 2. So the system has 4 poles, and so the order of the system is 4, but the number of poles at the origin is just 1. So this is a type 1 system. Let's see the next example. S plus 4 divided by s minus 2 into s plus 0.25. Again, the order of the system is 2 because the highest power of s is 2. And you have a 0 at s is equal to minus 4. You have 2 poles, one is at plus 2 and the other is at minus 0.25, which makes it very clear that you don't have any pole at the origin, which means this is a type 0 system. In the third example, the expression is 20 into s plus 2 divided by s square into s plus 3 into s plus 0.5. Again, according to this expression, you have a 0 at minus 2. The order of the system is going to be 4th order system, and you have 1 pole at minus 0.5, 1 pole at minus 3 and 2 poles at the origin, which means the system is of type number 2. And in the last example, the expression is 10 divided by s cube into s square plus 2s plus 1, which makes it a 5th order system. And as you can see, you have 3 poles at the origin. So this is going to be a type 3 system. Thank you.